Hi there, everyone. This is going to be the review for chapter 10 and 11. And so I've got my laptop, kind of like if you watched the one I did for chapter 6. I'm going to have to kind of lean forward every once in a while so I can look at the problems on my laptop. And my cat has decided to join me here. We'll see what kind of problems she poses while we're working these out. So I'm looking at the review. I suggest you do too. Maybe have quadratic formula up and written out someplace. I would encourage you to do that on the test as well. So it's readily available. The steps to complete the square, I definitely would have those handy also. So number 1, it says write answer using radical notation, simplify. And so it looks like on question 1, we have the square root of 80 x to the 5th. So this goes back to 10.3, I believe, in the simplification of radicals. We're going to break this down. You can break it down any way you want. Just get it to a product of primes. Any pairs that you see, because it's the square root, so we're circling things in pairs. So any pairs you see, circle the 2's, one guy cancels. Circle the 2's, one guy cancels. Anything that's circled is going to break outside that radical. So this 2 comes out, that 2 comes out. 2 times 2 is 4. This 5 is not circled, so it's going to stay underneath the radical. X to the 5th. You can either write out all 5 x's, you have a pair, cancels, you have a pair, cancels. X times x is x squared. 1x is left over or a remainder, and so that x is still underneath the radical. Another way to do that is just to take that 2 and divide it into that 5. So you know you have 2 x's on the outside. And the fact that there's a 1 right there tells you you have x to the 1st power underneath. So however you want to think about those variables, whatever's easier for you. Number 2, write using a radical expression. So from our lesson in 10.2, roots grow on the ground, powers or exponents are up on top. So we have x to the 3/7. There's parentheses around there. Don't let that impact your thinking. It doesn't really make any difference. This is the root, this is the power. So we have the 7th root of x to the 3rd. Or you could write it as the 7th root of x to the 3rd. Both of these would be acceptable answers because they have the exact same meaning. Number 3, when you have a negative under the radical, this lesson comes from 10.8. This one is difficult. It's an easy concept, but somehow it's difficult to kind of keep in your head, difficult for students to remember. You want to pull out those negatives. We kind of call it in the math world pulling that I outside the radical before you multiply. So this is going to become the square root of -1 and the square root of 81. The square root of -1 is I. That is the definition of what I is. And the square root of 81 is 9. So this is 9i. Same idea over here. No reason to show all your work if you get it. The square root of 169 is 13. Pull out the I. Now you're okay to multiply. 9 times 13 is 117 I squared. I squared is equal to -1. That's another little fun fact that I might have right there at your desk. You're going to be given a lot more materials here than you would be in the classroom, so that's kind of nice. I wouldn't make you memorize quadratic formula, but I would make you memorize the steps for completing the square. So -117 is our final answer. Oh, I scrolled too far. Hold on. Question 4. All right, so 25 to the 3/2. There's going to be one similar to this on the test, perhaps even two kind of like this, but they work out nicely. Root exponent. So this is saying, what is the square root? Do the root part first. And this is question 4. Do the root first. So the square root of 25 is 5. Do this part second. 5 to the 3rd power is 125. There are ways to use your technology just to type this in if you have any kind of scientific calculator, or if you know how to use the calculator on your phone turned horizontal. But if you're moving on to college algebra, pre-calc, those things, you need to have those skills up here without that use of technology. All right, just like I said, question 5 is almost the same. So 64a to the 4/3. The variable part, just write down and leave alone. So 1 times 4/3 is just a to the 4/3 power. The 64, though, however, will simplify. So root exponent. The cube root of 64 is 4. 4 to the 4th power is 256. Done. Question 6. All right, notice how we're doing on question 6, we're multiplying those radicals, but we're taking the 4th root. So we need groups of 4 in order to break out. Oh, the dogs in the neighborhood are barking. I don't know if you can hear that on your video. Whenever someone walks around the back lake, all the dogs go crazy. So go outside, Mabel. All right, let's see. Hopefully she'll go outside. Okay, so I would multiply these two. There she went. All right, I would multiply there first. So 20 times 4 is 80. A to the 3rd, a squared. Add those together. B to the 7th, b to the 5th. Add those together and get 12. And we're talking about the 4th root. Break it down like we did for the square root. So 2 and 40. I think we just did this same number in question 1. Notice how I have 4 4s. We need groups of 4. Cancel, cancel, cancel. The only thing, when you circle something, everybody cancels but one number. So that breaks out, and that 5 is still stuck underneath. So we have 2 on the outside and the 4th root of at least 5. Now I would take these exponents and divide them. 4 goes into 5 once. Multiply that out. Remainder of 1. That means 1a goes out and a to the 1st is stuck underneath. Let's divide these exponents. So 4 goes into 12 3 times with no remainder, which means b to the 3rd power is on the outside of the radical. So there's your final answer there. Number 7. I like this one. It looks more complicated than it is. Hint, hint, hint. If you're watching the video, there's got to be some advantage to that. Let me try to switch. I don't know if it's easy to see that blue marker. It seemed a little light. All right, 25. Oh, much better. 25 to the minus 1/4 over 25 to the minus 3/4. This is question 7. All right, notice how you have these negative exponents. So let's flip them, write the reciprocal. When I bring this up to the top, that becomes positive. It's still 3/4, but it's gonna become a positive 3/4. When I take that and make that exponent positive, now it's just a little bit easier to look at. Now remember the rules about exponents. If we have something like this, x to the 6th over x squared, we subtract these, that was circled strangely, we subtract those two and we get x to the 4th. Same thing here. So we have 25 to the 3/4 minus 1/4. We subtract those exponents. which leaves me 25 to the 2/4, which is really 25 to the 1/2. If the bottom number is the root, that really means the square root of 25, which is just 5. So all of that simplifies all the way down to the number 5. Okay. 28. Again, we have a negative exponent, I think, as I'm glancing at it. Yep. So if it's 1/27 to the -1/3, this stays a fraction, but in order to make that exponent positive, this 27 jumps up to the top. The bottom number is the root, so what's the cube root of 27? 3. And that's the whole thing. If you know how to type that in, you can type that into your calculator and it will also just spit out 3. But there's a lot of parentheses, the exponent key, you got to use the proper negative. So you might want to mess around with that technology if you choose before the test. All right, number 9 gets into division. I'm thinking about what lesson that is, 10-4, 10-5, maybe 10-5. The key to doing these division problems is to reduce the fraction first before you try to simplify the radical. So I am going to ignore the radical. And so you might even want to do that. We don't want to look at that radical quite yet. Is there anything there I can simplify? Well, between 10 and 72, we can reduce by a factor of 2, so we have 5/36. I have a to the first over a to the third, so one of those subtracts into that, and I'm left with a squared. And I have b squared over b to the first, so this cancels, and 2 minus 1 leaves 1. So now I'm going to rewrite it with the radical. Everything is reduced. I have 5b over 36a squared, all underneath that radical. The rule says I cannot end up with any radicals in the denominator of the fraction, but 36 is a perfect square, and a to the second is a perfect square. So we have the square root of 5b over 6a. And that's your final answer. You're allowed to write it like that, and there's nothing else you can do. All right, number 10. Now we have groups of, we have the 5th root, and so we have the 5th root. I'm unable to order them, order the problems so that they go in the same order as the book. When I was able to make some changes. I was able to combine chapter 10 and 11. I was able to take out the real challenging rationalizing ones and some of the more challenging solving ones, but it doesn't let me scramble the order. So it kind of jumps back and forth. So now we have 5th root. Multiply first. So 3 times 81 is 243. X to the 4th, x to the 1st, x to the 5th, y to the 4th. I think I'm just being redundant here and asking you a lot of these that kind of have the same concept. The more I ask, the more you can miss and still get a really good grade. So now we're going to break this down. It came from multiplying 3 and 81. So you can start there. 81 is 9 times 9. 9 is 3 times 3. You'll see here pretty quickly that you have 5 3s. We need groups of 5, and you have 5 3s circled. All of those cancel, and that guy breaks out. 5 divides into 5 nicely with no remainder once. And 5, there is, if you only have 4 y's, you don't have a group of 5. So just keep it underneath the radical. And that's your final answer. 16 is It looks like it would be more like what we just did with the 110 and 72, but this is actually just from, I think, 10.1, because everything's a perfect square. So this just kind of reminds you that when you see those perfect squares, you don't need to break it all down. You have 16m to the 6th over 9n squared. I wrote it as two separate radicals. It really comes like that. It's got the same meaning either way. Square root of 16 is 4m to the 3rd, because we're going to divide that by 2. The square root of 9 is 3, and then just a single n. Done. Number 12. Rationalize the denominator. The problem I gave you on the review is about the same level of difficulty as the one I chose for the test, so there aren't going to be any we skipped some of these ones, so I didn't make it with lots of variables or anything like that. Just do you know the basics? So whatever that is, you multiply the numerator and the denominator, so you don't change the value. So now we have 7 radical 2 over the square root of 4. So that's 7 radical 2 over square root of 4 is just 2. 13 looks again trickier than it is. Hint, hint, hint. So we have the cube root of x to the 5th over the cube root of x squared. No different here. Reduce that first. Remember that rule that if you have exponents in the numerator and the denominator, they subtract. So 5 take away 2 is x to the 3rd in the numerator, still underneath that cube root. And these two things basically cancel each other out. When you cube something and you cube root it, those are inverses. Or you have 3 x's and 2 of them cancel. However you kind of think it through, your answer is just x. We're almost done, I think, with the chapter 10s. Number 14. We need to simplify, and then if we have like radicals, we're going to add those together. So 14. 5 radical 12 plus 16 radical 27. So 12 is 2 and 6, which is 2 and 3. So we have a pair of 2's. That 2 comes out, but there's already a 5 there, so everything is multiply. 5 times 2 is 10. That 3 stays underneath. 27 is 3 times 9. 9 is 3 and 3. That 3 comes out, times that 16. 3 times 16 is 48. This 3 right here that I've underlined, that's that 3 right there because it didn't have a buddy. Since the radicals are the same, the coefficients can add together. And that's our final answer. 15 is a FOIL. Oh gosh, that's really similar to the one that ended up on question 16. Okay, so first out in last, or just distributing through both terms in the front. So 1 times 5 is 5. 1 times 2 radical 2 is 2 radical 2. Negative times 5 is negative 5 radical 2. And that negative is attached there times that. So put the 1 there if that's easier for you. So negative 1 times positive 2 is negative 2. 2 times 2 is the square root of 4. You can rewrite all this, but the square root of 4 is 2. 2 times this 2 is 4. So when I tend to do this, I just kind of scribble the back a little bit without rewriting the whole thing. I showed you rewriting it in the notes on the chalkboard so that you could see all those steps. Sometimes, not always, there are like terms. So you have a positive 2 radical 2 and a negative 5 radical 2. So that's a negative 3. That radical 2 doesn't change, just gets tacked on to the end. And that 5 and that negative 4 are like terms. 5 minus 4 is 1. On 16, one over 5 minus radical 2. Okay, so this is called the conjugate. All we do is we change that middle sign. Everything else stays the same. So we're going to multiply both the numerator. Look at how I gave it to you as just being a 1. And I think I did the same thing on the test as well. It didn't used to be, but I'm trying to kind of streamline again. So this is kind of just done, because when you multiply through by 1, obviously it's just going to be that. So the numerator is going to be 5 plus radical 2. The denominator we need to work out. Remember, there's no radicals in the denominator allowed. So let's FOIL it. 5 times 5 is 25. When I do the outside piece, plus 5 radical 2. When I do the inside piece, minus 5 radical 2. And when I do the last piece, I'm going to get a negative square root of 4. When it's a positive and a negative, those guys just cancel out. So the radicals are gone. That's the whole reason you do this method. The square root of 4 is 2. 25 minus 2 is 23. So, all right. Forgive me. I think people are in need of my attention real quick, and then I'll go back to 17. Yeah.
Do we have playing cards?
Oh, absolutely. In the desk. If you pull out, there's a multitude of variety of those.
All righty.
My son attends the City of Peoria programs for after school, and they have continued to do home visits. And they hang out on the driveway. It's been really nice for them. So, okay, 17. Solve, we have this. Did you find what you're looking for?
Yeah,
Sam?
I found the Simpsons one.
Perfect. Okay.
I'm also going to grab one of the things.
Okay. This is a positive 4 right here. Notice that positive 4, that radical ends right there. So the positive 4 is going to jump to this side because our first step is to get the square root by itself. So this minus 4, so it's going to be a negative 4 on the left. And so once we have that radical alone or isolated, we are going to square both sides. When you square this side, you're going to need to write it twice and FOIL it out. Because it's not just x squared minus 16, or even x squared plus 16. It's going to be x squared minus 4x plus 16, or x squared minus 8x plus 16. When you square on this side, one of the big ideas of this unit is that radicals and squaring are inverse. They undo each other, so you literally can just scribble it out. So this side is just 2x minus 5. All right, we want to move everybody to the left because as of this point, the only way we know what to do is to factor. So we need it equal to 0. We're going to factor and solve. So we're going to subtract the 2x. We're going to add the 5. I'm going to write it over here. X squared minus 10x plus 21. And then I'm going to factor, so we have x minus 3, x minus 7. So x equals 3. and x equals 7. And then it's really necessary to go back in and check. Oftentimes, unless you end up with like maybe someplace where you had a negative, it's going to check out fine, but not always. So plug in 3 and plug in 3 and let's see what happens. 2 times 3 is 6 minus 5 is 1. That's underneath that square root, so the square root of 1 is 1. 1 plus 4, oh look at that. 1 plus 4 is 5. 5 is not 3. We gotta cancel that one. Let's try to plug in 7. So 2 times 7 is 14, minus 5 is 9. The square root of 9 is 3. Plus 4 more is 7. 7's on the right, 7's on the left. 7 checks out fine. 18 is markedly less complicated than this one. So again, bear with me. I couldn't go easiest to more difficult because of that scrambling issue. So 18, the first thing we're going to do is move that negative 7 to the right. So now the radical is isolated. Negative 4 plus 7 is 3. We're going to square both sides. That's going to kind of kill that off there. So x minus 2 equals 3 times 3 is 9. Add the 2. So x is simply 11. Let's plug 11 back in just to double check. 11 minus 2 is 9. It's underneath the square root. The square root of 9 is 3. Minus 7 is negative 4. And that equals negative 4. So we're good with that. All right. 19 and 20. Oh, 19 and 20. And then I think I'll stop that video and just do chapter 10 on one and the problems from chapter 11 on another, so that if you're looking for one specific one, then I can kind of go check on my family real quick. So I have 2 plus 7i minus 1 plus 8i. And so I need to distribute that negative. One of the things that was a commonly missed question on the chapter 6 test was there was a place with the fractions, and sometimes some people are still forgetting to distribute. So we just need to make sure we multiply that through. So this becomes a positive, and that becomes a negative. 2 plus 1 is 3. A positive 7 and a negative 8 is negative 1. I. The I term always goes in the back, and you always separate your terms. You would never have something like this, totally unrelated to this, I'm just babbling. You would never leave your answer like that. You would split it so that the 3 would go underneath the 5, and then the 3 would go underneath the 8, and then the I would be tacked on to the end. And so just to remind you that that's one of those little rules. And number 20, we're gonna FOIL with I. You can tell it's FOIL because again, there's no sign in between them. And it says multiply. So 2 times 3 is 6, minus 4i, plus 15i, and then that back part we have a positive 5 and a negative 2, so negative 10. I times I is I squared. That rule that came up earlier, I squared is equal to negative 1. So that changes this to a plus 10, and the I is gone completely. So 6 plus 10 is 16. A negative 4 and a positive 15 is positive 11. And that's it. There are no rationalize the denominator with I on the test. So there's nothing that's going to look like this that I secretly put on the test where you have to multiply top and bottom. I had you practice that for homework, but I left it off the test because I feel, oh, now it just scrolled all over the place. I feel like if you could do that other one, you could do this one as well. So, so that will not be there. All right, this concludes all of the chapter 10 questions, and I will start up again at some point, and I'll start with question 21. So hope you guys are doing well. Hope these videos are really helping. Let me know how I can help you be successful on these last two chapters. So thanks for watching.